Okay, it's I'm going to start. So hi everyone, I'm Iván Paz. This is ICLC 2024. First of all, thank you to the organization for these big efforts, and thank to all of you for being here and to share this. I'm going to talk, my presentation is called Symbolic is the New Life. So before starting, just a small disclaimer. I feel part of the Top Lab community of Barcelona, the live coding community of Barcelona. I also feel part of the Top Lab community in Mexico, mainly in Mexico City, but in Mexico. So also, I have to say that it's 11 a.m. in Shanghai, but it's 5 a.m. in Barcelona, where I'm located. So please, this is a great excuse for a provocative, also speculative presentation, because I can just say, like, don't take me too serious. But this is the starting. In Valdivia, in the ICLC conference in Chile in December 2021, I wrote a paper together with Shelley Knott, a life coder, that probably you are familiar with her work. Because me and Shelley, both of us, we were using life coding and machine learning. We were using machine learning in our life coding practices. I don't know, maybe because we both are Super Collider users, and the abstraction level of Super Collider probably asks sometimes for extra abstraction layers to be able to perform. So we wrote this paper. It was also a bit provocative. The idea was stealing something from the draft manifesto and saying, okay, live coding and machine learning is dangerous. Show us your algorithms. And basically, this paper was analyzing the live coding machine learning intersection from the lenses of the draft manifesto. So in the very sense of the ideas in the Changing Grammars Symposium in Hamburg in 2004, this idea of what could happen if we change the grammars or the rules as we speak. So many of the ideas of the live coding ethos, like programs are instruments or algorithms are thoughts, and live coding is like thinking in public. So that we would like insight into algorithms, and we love the skillful extemporization of an algorithm as an expressive, impressive displays of material dexterity. So these ideas is like we like to displace. Live coding has a lot to do with displaying algorithmic processes in real time, like a conversation. So this paper essentially asks like how machine learning algorithms could be displayed and how they're being displayed. And we were discussing the tensions between these two contrasting ethos. Let's say the openness, the liveness ethos of the live coding, and the ethos of automation, optimization, ideas of the machine learning processes. So we continued this work. We wrote another paper because we had not many things to do, probably. So we wrote another paper that was just published last year. And the idea was, okay, we have been discussing these two contrasting ethos, what happens, how the algorithms are displayed. So we looked a bit closer in the ideas of finding the moments of interventions in autonomous processes. The idea was to look, okay, we are using machine learning, we are using live coding, and where in the machine learning process, when we are doing live coding, we can actually act or intervene. So the idea was in which places we actually intervene. when we are using machine learning in a live coding performance. So we were also considering the time constraints related with the data size of the algorithmic processes and with the very algorithmic processes itself. So to me, this is a bit like the live coding ethos. This is a quote from Julian Rohrhuber in the keynote of the ICLC 2015, which basically the moment computers were faster than the sound they need to produce was like the condition, the very condition of live coding. So when we are doing machine learning, these time constraints of the algorithmic process, the training time, the time we need to evaluate a model, the time we need to collect the data are big constraints that allow until some point to display these learning processes in real time. So this has to be, or to do a lot with the small data and with the capacity, the time constraints that we have right now in the machine learning process. So in these papers, of course, we include a table because it's a paper. Papers love tables. So we were analyzing a lot of live coding systems. We can see many of the systems, probably you know some of them. And we were looking at the action that actually happens in real time, mid-performance or during the performance. So the red dots indicate we separate the process, the machine learning process, in the data acquisition, data cleaning, model selection, training, evaluation, etc. So in red dots, we have the systems or the part of this process that for each system actually happened in real time. So in this paper, this contribution for the ICLC, this symbolic is the new life, what I'm asking is, why do the systems that are intervened during the performance share? And it's not about the possibility, because many of them can actually perform many of these processes like data cleaning, data collection during the performance. But what happens when we see people using this system and playing with this system? What do these systems actually share, the systems that are being used in real time or in a performative way? And basically, what I can see is that these systems, they share the use of symbolic algorithms and also the use of small data, at least most of them. Of course, it is really hard to generalize, but most of them, they use symbolic algorithms that we can interpret or that produce interpretable models. And they also use small data for actually being trained, to have the possibility of being trained in real time or collecting data in real time. So again, it's just a provocative or a speculative way to point out that maybe symbolic algorithms and the small data are quite of promising paths for experiment for what we have right now in a live coding setup. And basically, they allow us to actually explore the expressiveness that results from its material possibilities, the materiality of the learning algorithms. And I have to define this materiality, this material property, this material quality of the algorithms, that to me is the possibility of changing the parameters, changing the data sets, collecting the data sets, retraining, and unfold and explore the performance, the sound, or the visuals that the different intervention of these processes of the machine learning process itself can offer in real time. So it's like unfolding the performance, like playing with the sound that results from this interventions in the materiality, in the very materiality of the algorithms. So it's displaying these algorithms as a conversational process. So I'm just going to show you some examples that are in the paper. This is Migra. This is a live coding language from Niklas Rebel, one of the members of the Barcelona community, live coding community. And what Niklas is doing is, this is, I don't remember, but this is from this year. Niklas is playing with the genome using We Love Cats in Top Lab Barcelona. And Niklas is playing with the genome of all parts, of course, just a part of the genome of the Felis catus. And with Migra, actually, Migra uses Markov chains that are quite interpretable. Its output is really interpretable. So Niklas is playing by changing the input data, producing these graphs, and each node of the graph is associated with a particular sample, in this case. So by changing the input data and by retraining the model in real time, then it's possible to have different qualities of the song, different rhythms, different patterns, different combinations. So by exploring this and retraining the model, Niklas plays or did this particular performance, and some of the performance he has been producing recently. Also, this is a rule. For some of you that are familiar with rule learning, this rule is like, okay, if parameter 1 is 5 or 7, and parameter 2 is either low or mid, then the result is harsh. And this is a system. This type of rules is a system that I use. It's called Ruler, that also allowed me to train using different input data, changing only 2 parameters, because this algorithm is designed to be able to be configured by only changing 2 parameters. And the rules I'm producing allow me to have different qualities. In this case, I'm using data, small data, to change to produce sound for a specific synthesizer. So again, using small data, then I'm just sending basically the resulting rule to the sound algorithm, and the performance again unfolds as this data is changing and then is producing different sonic outputs or sonorities for this synthesis algorithm. So again, Symbolic is the new life. It's basically speculating a little bit about the possibilities that symbolic machine learning algorithms combined with small data can offer, or the possibilities to use this, or why these are being more used as a part of a real performance in comparison when subsymbolic algorithms, like probably the more famous are neural nets. And of course, I'm not being purist. We can also combine these 2 possibilities, this metaphor of the black boxes of the neural nets or transformers that are also being recently used in live coding, with this idea, maybe using this small data, neural nets or transformers to produce the raw material, and then these symbolic algorithms to conduct the high-level form of the musical piece of the performance. These slides are from a course from the UPF here in Barcelona. And so this is the basic idea. Analyzing these systems, maybe we can find something interesting. And so this is everything on my behalf. Thank you for listening. Also, you have my contact over here.